All right, we had a question here in regards to a problem that's found in section 13.1. It's number 19 in that homework exercise set. Now, the numbers may be a little bit different as it kind of randomly changes numbers for your particular question, although the overall question is going to be the same. And so the question was, how long will it take to double your money in an account that pays 5% compounded quarterly? And so as we go to do this, we want to make sure that we are aware of the accumulated amount for compound interest formula, right? And you'll have that. Sorry, I didn't mean to put an equal sign in there. Let me go and back that out of there. It's P times, and if you remember, 1 plus R over N to the NT. And so you're familiar with this formula. The student that asked this question didn't have other questions, so he's been using this formula. And we need to use it to double our money. And so as we come in here, we can place things that we know. We know what R is. And so let me come in here with a different color. We know that R is 0.05. And coming back, just putting in what I'm inserting in blue. N is the number of times it's compounded. It's compounded 4 times a year. And so we have the 4 times a year. And we need to solve for the time t. T's the, I'm going to put t in red. T's what we really want to know. And so it's a very interesting question as we go through here. So the problem is they didn't give us a starting amount. It doesn't matter actually what you start with or what you end with. The time it takes to double will be the same. And so sometimes I'll just tell students, hey, make up something. And so if I make up something, let's suppose I started with $100. If I want to double it, I'm going to put 200. You could also picture 1,000 and 2,000, all of that stuff. Well, if we're going to do that, then no matter what numbers we pick, our first step, if we're going to solve for t, would be to divide this side by 100. And so those are gone, and I get a 2. Now remember, it wouldn't have mattered if it was 1,000, 2,000, 100, 250, 100. As long as that first step is going to be division. As long as I have the number doubled over there, I'm always going to get a 2 here. And this is equal to 1 plus 0.05 over 4 to the 4t. And so as we look at this problem, just trying to see where I set my calculator, we're going to have to do something in order to get to that 4t. And so this is probably one of the only problems where you're going to have to solve for t. And so let's do that by taking the logs of both sides. So log 2 is equal to log of 1 plus 0.05 over 4 to the 4t. And the reason why we're taking the logs is because with the logs, we can now bring down the 4t. And let's figure out what 0.05 divided by 4 is, so we don't have to keep writing that. 0.0125. Okay. And so if I clean that up just a little bit, I have log 2 is equal to 4t, and all I'm cleaning up is the stuff in the parentheses, which is 1.0125. So the logs are very helpful. It's found on your calculator, but the property of the logs that we're using is it can take this power and have it come out front as a factor. Well, that's good because it gets the t that I want down. Well, if it's t that I want to solve for, right, the whole time I've been focused on solving for this t. So here it is up in the exponent. Don't like it up there. Now I get it down here. Well, if that's the thing that I want to solve for, then I just have to do the opposite of what's there. And I'm going to divide both sides by 4 log 1.0125 and divide this by 4 log 1.0125. And so actually that solves for t. So t will be in years. Let me space that down a little bit more so I don't run into the top. So here we got t is equal to, and then we just plug it into our calculator. We just hit log 2. So I find my log button, Mine opens up with the parentheses, so I do log 2, and then I'm going to hit divided by, and in parentheses, I'm going to type in 4 times log of 1.0125 and close the parentheses. So the way I typed it into my calculator was log, my calculator opens up with an open parentheses, 2, closed it, divided by, and then I used an open parentheses and did 4 times log of 1.0125. And so that's going to do this product before it does the division, which is important. Otherwise, it would do the division first because it works left to right. And here's what comes out of my calculator: 13.949,40762. So that's telling me that it's going to take almost 14 years to double. Now, they wanted the answer says ignoring leap years, they wanted the answer in years and days. Well, 13 is the years, so I got that. So in terms of, it's 13 years, and if you want to find out the number of days, you take that decimal part, the 949,40762, and you multiply it by 365. That's what they mean by ignoring leap years. So to get the days, I'm taking the decimal stuff, the stuff that's not the 13, the fraction of a year, and multiplying that by the 365 days to figure out what fraction, well, we know the fraction of it, but to figure out how many days that is. And let me do that. And I get 346.5 days. So I would put 347 days. The result of this, just, I said it, but it might be easier if I wrote it, look like this. And it just kept going. So I did natural rounding to 347 days and 13 years. Not surprisingly, we know there's 365 days. We're almost there with 0.949 of a year. But that's the way I would do it using the accumulated amount formula. It is possible that our book has a formula to solve for t that's already done, but I think we'll have to go through these logs in order to get it. So that's the key there. So hopefully this video helps. Reach out to me via email or come to the Zooms if you have further questions. Thanks so much.